Now let's pay attention to how this last example is stated. It says simplify. What's really nice about this is we just have to worry about the simplification of it instead of worrying about where it's defined, because in all three questions they said where exactly it is defined. So when we're talking about this one, a, 7 root m plus 2 root n plus 5 root n minus 3 root m. I'm just going to do what we did in grade 9 and highlight the like terms. And don't forget to take in the sign that's in front of it. So 2n, 5n. So what I'm left with here is 7 root m minus 3 root m, and I get 4 root m. 2 root n plus 5 root n is going to be positive 7 root n. And we don't have to worry about defining where it is, where it exists, because we have that definition right there. All right, so now we have another example. I have 2 times the cubed root of negative 3b. And I only have a like term with this right here. Why? Because the index on this is 3. Okay, it's the cubed root, whereas this has the same radicand, but it has a different index. So I'm going to color it in a different color because it is not a like term. So it's worth pausing for a quick second here. B is less than or equal to 0. Let's think about it. So we don't have to worry about the cubed root because, like I said, it's a heyday. But if we were to plug in a positive number when it's a square root, say I said b equals 1, that means that we would be finding the square root of negative 3, which doesn't exist. But if we put in is less than 0, that means that if I have, say, negative 1, negative 3 times negative 1 is positive 3. So if we have a value for b that's less than 1, it's going to multiply by that negative 3 to create something positive. So that's why it's important to pause for a second and make note of that. We did an example in the last lesson like that, but it's a pretty abstract concept, so it's good to note it several times. So I have 2 of this quantity here, and I want to subtract 9 from it. So I'm going to get negative 7 root 3 of, or sorry, the third root of negative 3b, not root 3, but the cubed root of negative 3b. And I have 8 of this quantity, and I want to add 3 to it, so then I'm going to say that that is plus 11 times the square root of negative 3b. Done. And we can't simplify it any further, though we would like to. There are similar things about it, but that's as best as we can do because the indices are different. Last but not least, this one, number C, or not number C. Don't you hate it when teachers do that? Letter C. We know that A and B are both greater than 0. This makes us really happy. Since they're greater than 0, no need to worry about absolute value bars. Because we know that the square root of a squared will be positive, because a is positive. So we need to do some simplification here. So I'm going to say, okay, 3 times the square root, and I'm going to break this up into its perfect square factors. So, so in this one right here, I know 32 is 8 times 4. But there's a bigger perfect square factor, 16 times 2. And I'm going to break this up, so a to the 4 times a, which gives me a to the 5, but I know that a to the 4 is a perfect square factor, okay? Minus 2 times the root of 9 times 5, because 9 is a perfect square factor, times b squared times b, to give us our b cubed here. And then I'm left with plus 5b times 125, which is 25 times 5, and I'm left with b, and there's nothing to take out there, minus 2 times a times 36, which is a perfect square factor, times 2 times a squared times a. Whoop! Okay, that's a lot of work to do, and that's a lot of things to keep in mind, but that's why we want to we don't want to do these things too quickly. Yeah. So I'm going to split them up into their perfect square terms. So I'm going to pull out the 16 and the a to the 4 and the 9 and the b squared. I'm just going to do that. I'm just going to do the simplification of perfect squares at this point. So I say 3 times the square root of 16 times a to the 4 times what's left, times 2a, minus 2 times the square root of 9 times b squared. And then what I'm left with is 5b, plus 5b times the square root of 25, and what's left is 5b. And I do a little math happy dance because I'm noticing, okay, 5b and 5b, that's good, that's good. And what's tricky about this one is 5b is outside of the radical and underneath the radical, but these are different. Minus 2a times 36a squared times the root of 2a, which is good because it's a like term to that. So if I'm seeing some like terms forming already, that's a good sign. So I'm seeing 3 times 4a squared. So I'm just going to say here that 16a to the 4 is the same thing as 4a squared, root 2a, minus 2 times 3b, root 5b, and I'm just going to color this with a different marker. I'm saying that root 9b squared is the same thing as 3b. Plus 5b times 5 times root 5b. That's a lot of 5b's. But we're saying that root 25 is the same thing as our 5. And we're going to subtract 2a times, this dot always means times, by the way, times 6a times root 2a. And I just lastly want to say, okay, root of 36a squared is the same thing as 6a. Now, I'm going to say, okay, 3 times 4a squared root a is 12. A squared root 2a minus 6b root 5a plus 25b root 5b minus 2 times 6 is 12, a times a is a squared, root 2a. Now again, we're going to do a little math happy dance of joy, because I have like terms with this one and this last one. So not only do I have the root 2a, but I also have the a squared that's attached to it, which is important. And I have negative 6b root 5a. Sorry. Oh man, I'm so glad that I checked over that one. It should be 5. This one shouldn't be 5a. It should be 5b. I hope that hopefully you guys caught that. Alright, so now I'm going to do the final job in simplification. 12a squared root 2a minus 12a squared root a is just 0. So we're left with this one right here. Negative 6b times root 5b plus 25b root 5b. That is simply going to become positive 19b root 5b. Done. So first things first, I want you to go into your textbook and do the questions that I've assigned there. Secondly, you'll find in this notes package that there's some practice for 2.3. It's combined with some 2.2 practice, just in case you wanted to go back. It's good for review. to do that. But first do your textbook and then do the practice.